solution, which it can become active acidity, you have to neutralize that also. Okay. These two potentials and active acidity is the answer why your soil is acidic. So you have to neutralize both. Okay. And limey materials are also should be economical because it's expensive, kan? Okay. So in order for limey material to be economical, it has generally to be a salt. You tak boleh buat dalam bentuk air. For example, you put calcium hydroxide tapi dalam bentuk air because it can leach out. Okay. So how it reacts are like this. Calcium carbonate with the additions of water, it can form a calcium ion and also carbonic acid and also OH negative. So this calcium will sit, tak nampak sorry. This calcium will sit at the exchangeable site and this hydroxide will react with the salts and produce H2O, meaning they're neutralized. Okay, so that's why I put here the calcium displace the H plus, the calcium displace the H plus on exchange site while the OH negative neutralize the H plus and become water. Okay, so please carbonic acid is just a weak acid. Okay, so this is the liming reaction in the soil. Macam tadilah CaCO3 plus the H plus, the Ca will neutralize this one and it will produce H2O and also carbon dioxide, which this neutralize the H plus in the water. Dia jadi water, kan? Okay. So it will reduce, it will increase the pH. Okay, however, we also have what we call as soil acidity buffering, which actually the soils tend to buffer the pH. Okay, for examples, high clay or organic matter has a greater buffering capacity. What is buffering capacity? So buffering capacity is actually the soil capacity to resist pH change. Okay, so sometimes, okay, for examples, sekejap saya tunjuk sini the pH is 6.5. Okay, so you are putting, okay, dia ada beberapa jenis tanah. Saya compare yang paling rendah dengan paling tinggi. So this is sand. Okay, so this is what we call as clay. Okay, so clay kat sini CEC dia 25. Clay, sand dekat sini CEC dia 5. If you see here, the pH are the same, but sand require only small amount of limestone to increase its pH to 7. But clay loam require 500. Okay, mega what is this sorry, mg per hectare, okay, of liming materials. Maksudnya untuk naikkan tanah clay walaupun pH dia sama, so I speak in BM first, okay, I repeat in English. Untuk naikkan dua jenis tanah yang CEC dia 5, CEC dia 6.5 sama, pH dia sama 6.5, tapi dua jenis tanah berbeza because of the texture. Clay require more limestone rather than the sand. That is because of the texture. High amount of lime are needed for fine texture to increase its pH, although a coarse texture type of soil, for example here sand has the same pH, meaning that sand require about 100 ton per hectare, and also clay loam require about 500 ton per hectare of area of using the limestone to increase its pH. Okay, so soil it has a buffering capacity, okay, which the ability to resist of pH changing, but that's why you have to put more to rise its pH. Okay, so when you are putting liming, selalunya saya pernah pergi bawa students to area Kedah to observe a paddy field plantation, paddy field plant, okay, area. They did not put liming for like 5 to 7 years already. Why? Because banyak issue lah. But one of the matters is that we have lack of manpower, and also because the liming are expensive. But actually liming have a lot of benefit. You have to increase the soil pH towards neutral. That is because of macam tadi, nutrient is available at neutral pH kan, at pH 7. That's why you cannot let your soil to be in acidic conditions. Okay, so actually liming can provide a few benefits. Okay, first, it will reduce the possibility of aluminium and also manganese toxicity, because in low pH soil, the aluminium and manganese toxicity are prone to happen. Okay, not only that, it also can improve the microbial activity. Okay, as I mentioned just now, pH, lower soil pH will lead to what we call as will leads to apa lagi, inhibits the physiological and enzyme activity by the microbes. Number 3 is it improves the physical condition. Okay, the soil will have a better structure if calcium is at the exchange site. Okay, later saya tunjuk yang ni, gambar dia. Saya rasa dekat belakang. Number 3, it improves symbiotic nitrogen fixation by legumes. That is because it is ate by the microorganism. Number 4 and number 5 is provides an inexpensive sources of calcium, meaning that you don't have to buy a specifically calcium fertilizer, but you can just put the calcium lining atau calcium carbonate tadi. You also providing the calcium and also magnesium. Okay, sebab sometimes macam dolomite sekejap tunjuk. Okay, for example here dolomite. Okay, dolomite ni, okay, this is dolomite. It contains of calcium and magnesium, meaning that if your intention is to put the magnesium also, you can put this calcium magnesium carbonate dolomite. Contoh macam calcitic limestone calcium carbonate ni, it doesn't have what is that? It doesn't have magnesium. Okay. Okay, number 5, it improves the nutrient ability. Okay, so it helps to provide available nutrients to your crops. Okay, so calcium and gypsum, actually when you are putting the liming materials, it not only improving the pH but also the structure of the soil. Meaning that calcium ni, dia punya properties is that it carries a good characteristic for the soil to have a good soil structure. Okay, that is because of the valence. By time you akan tengok nanti sekejap lagi saya tunjuk comparison between calcium and sodium punya valence. Okay, so how is actually lime applied at field? So actually liming materials react slowly. It gradually the increase, as I mentioned just now, when you put fertilizer, when you put liming, not tomorrow dia akan effects. The effects of liming will be 6 to 12 months ahead. Sama juga untuk oil palm plantations. When you are putting fertilizer, it affects is a lot 1 year. Baru you nampak kesan dia. Okay. So rate of limestone applied is what you want to, when you want to adjust the soil pH, you have to know your pH level, your initial pH. Then what is your end pH and what is the CEC of the soil. Okay, that's the important parts of how you want to determine. Bukan main tabur je that what is that liming materials. You have to calculate. You have to do calculations. Okay, so if you are in UIA, I'll teach you in lab on how to calculate the pH. But I think it's not very convenient for me to teach you. But however, if you are planning to take soil concentrations, then we will learn about that later in soil management. Okay. So ini yang tadilah saya cakap, if you want to ameliorate the effects of soil acidity, you can put organic matter, because organic matter act as a pH dependent. Okay, so it can dissociates the H plus when the soil pH increase and reassociate when the pH drops. When you are putting the organic matter can helps like materials that neutralize or backward process. Okay, so it can identify whether your pH is acidic, or if it's acidic, then it will release the compound. Okay, so when it release the it will release the hydroxyl. Okay, so when hydroxyl is released, it neutralize the soil solutions. Okay, meaning that it neutralize the H plus. But if the pH is in basic, so it dissociates the H plus. Okay. Okay, besides that, also organic matter ameliorate the soil acidity by 3 ways. Okay, first, it humidify organic matter that can bind tightly with aluminium ions, and it prevent them from reaching toxic concentrations in soil solution. Number one, maksudnya dia organic matter ni dia hold the aluminium ions. Okay, number two is that low molecular rates of organic acid can produce a microbe decompositions and acidates, and it will form a soluble complexes with aluminium. Okay, so when it form a soluble complexes with aluminium, macam saya cakap, dia bonded. Okay, so it's non-toxic. Okay, sebab dekat dalam organic matter ni, dia ada banyak functional groups. If you see here, there is a lot of functional groups, and sometimes there is also cations attached to the organic matter site. So that can form a soluble complexes with aluminium. Okay. Number three is that amendments such as animal manure, for example, you are using najis lembu ataupun ayam, sewage sludge, it can combat the aluminium toxicity and raise calcium and also the pH levels. Okay, because the properties of the manure ataupun the organic compound can do that. Sebab tadilah, sebab dia ada banyak a few functional groups, and also what we call as apa tadi, organic acid, low molecular weight of organic acid. Okay. Okay, number two is gypsum. Gypsum is like calcium carbonate. It's like limey materials, but dia punya formula lain. It has a very soft mineral composed of calcium sulfate dehydrate. Okay, formula ni calcium sulfate. So it contains a calcium isosulfate, okay, which it is usually used if we have what we call as aluminium toxicity problem and also structure problem. Contohnya macam ada a few cases ataupun situation that the soil is dominated by sodium tau. Okay, so this sodium will make the soil structure poor, will make a poor soil structure. So how you want to improve the soil structure is you put gypsum. How it will act is that like this lah, nanti saya tunjuk. Okay, so gypsum is a widely available material found in natural deposits or industrial byproducts, and it does not increase soil pH, but it helps to combat the aluminium toxicity. Okay, so it is more effective than liming in reducing the exchangeable aluminium in the subsoil. So how it acts is that so macam saya cakap tadi the calcium is contains of calcium sulfate. So calcium are separated into calcium and also sulfate. Okay, so this calcium will sit at the soil while the aluminium will be bound to the hydroxide. Okay, so by here, the metal salicylic acid is weakly dissociated, much less so so that the clay absorb the H plus ions. Okay, so the clay will absorb the H plus ions, and the pH of the soils will rise. Tapi the main intention is not this. You kena faham the actions of liming just now adalah yang 3 tadi saya tunjuk you, and the main reason why you should put gypsum is because of this. Okay, however, the pH of the soil to be changed are slightly minimal lah. Okay, so this is the comparisons of the liming and gypsum reactions. If you see here, the most important is the calcium will sit at the exchangeable site of clay, while in liming you produce the water, meaning that you neutralize the H plus, but in here the H plus are still there. Okay. Okay, kita pergi sikit lagi. Banyak lagi. Okay, saya nak pergi sampai sini dulu, sampai sikit lagi. Okay, so settle dengan kawasan acidic area. That is macam kawasan kita. Tapi macam saya cakap, in Mediterranean areas, okay, which is in dry area, which you have restricted content of fresh water. Okay, so limited rainfall which is less than 800 millimeter. Okay, so there is a shortage of water supply and also moisture, and in this type of soils the growing seasons are less than 200 days. Maksudnya you tak boleh tanam sepanjang tahun. Okay, there is having a constraints of wind and water erosions. Dia berbeza sedikit dengan air dekat Malaysia, cuaca dekat Malaysia and tanah dekat Malaysia. That is because the main agent, which is the water, is not there. So kawasan macam kawasan Arab adalah berbeza sikit. So problem with the dry region area is that the water is limited. Okay, so macam kat kita acidic soil kan, tapi kalau dekat Arab is that bukan Arab je, banyak lagi kawasan Amerika, Afrika yang lainnya hadapi benda ni. Tapi itulah macam Arab kita nampak dia macam desert kan. Okay, so usually kawasan tu has high pH. That is because there is no rain, which contribute to less solubilizations of calciums and all the cation. Maksudnya cation ni, calcium, magnesium ni, dia duduk dekat exchangeable site and cause another problem. So the problem is that in this type of soils, the carbonate are rich in nature. Kejap hari hujan. Saya tutup ni jap. Okay, so apa dia? Ada siapa-siapa cakap ke? Tak ada. Okay, on this type of soils, it causes a alkaline soil that have excessive levels of salts and sodium. Okay, there is a lot of salts and sodium lah. Okay, so what problem arise is that there are about 3 problems, which we have a calcium-rich layers. Number 2 is nutrient deficiency. Although calcium and magnesiums are high, but we have another problems, which are problems in, for example, micronutrients and zinc, copper, chromium tadi dia perlu slightly acidic condition kan, tapi in high pH nutrients ni tak available. When we talk about nutrients available in what form? Nutrients are there. Contohnya macam zinc boleh ada kat kawasan tu, tapi is it available to the plants? Okay, so available ke or tak available or not available is depend on the pH of the soil to make it available or not for the crops to uptake. Okay, so number 3 is colloidal properties, which is the CEC and also clay distribution. It affects. Okay, so we go one by one. Under a low rainfall area, okay, there is an accumulation of calcium carbonate, okay, which it forms a calcic horizon. Kita call it as a calcic horizon. Okay, so this is the calcic horizon. Macam saya cakap tadi, when there is accumulation of calcium, dia ada lapisan yang keras. So this hard layers of soils will make the roots to grow will restrict the growth of the roots. Okay, number 3 is that the high carbonate concentration will cause deficiency of micronutrients and phosphorus. Macam saya cakap tadi, phosphorus are sensitive tau. Phosphorus tadi, if the pH are very low, it tend to bounce with aluminium. But if the pH are high, it tends to bond with calcium. So phosphorus yang tak available, will not available for the crops to uptake. Okay, so high carbonate concentrations will cause the deficiency of micronutrients, because remember dengar micronutrients in soils are usually available when the pH are slightly lower. Okay. Okay, so in calcium rich soil, pH is always like 8.5, mostly 8 to 8.5 lah. Okay, so in these types of soils, nutrients, also nutrient deficiency lah macam saya cakap tadi. Okay, so in alkaline soils, solubility of nutrients are reduced. Magnesium, copper, ferrum, zinc are readily available in soil, but at high pH it is less soluble. So examples for phosphorus, it will tend to bond with calcium. Dia jadi compound. Okay, it turns into compounds, and that phosphorus which you put is not available for the plant to uptake. Okay, ingat nutrients in soil have to be stable, sebab when it's in ionic form, dalam bentuk cations or anions, it tends to react between each other and dia akan form a compound. Bila form a compound, akar tak boleh absorb that compound. Dia kena in cations. Roots only take nutrients in ionic form. Okay, so for examples, when it change into calcium phosphate bonded together, calcium phosphate, the phosphorus cannot be uptaken by the crops. So it restricts other nutrients because of the high calcium. Okay, number 2 is colloidal properties. Number 3 okay, so colloidal properties is the CEC. CEC are high in alkaline soil compared to acidic soil. Okay, so in 2-to-1 types of clay are most common in alkaline soil. That is because of the high amount of the permanent charge, meaning that if the K sit there, only K sit there. Okay, so number 2 is that high pH stimulate high levels of pH dependent charges on the soil colloid. Okay, so at low pH, soil charges will become more positive. At high pH also, however, at high pH, the negative charge increases and overall charge will become negative. So if you see here, at high pH dia jadi O negative macam ni. Okay, neutral pH is like this, and at lower pH is like this. So what does it affect here? Okay, it will affect the availability of the nutrients. Okay, so it depends on the pH. Selalunya kat sini kita kena we call it as a permanent charge. Dia hold that tightly. Okay. Sekejap Okay, the last one I guess. Okay, so the colloid, lagi satu adalah the effects the colloidal properties. Colloidal properties ni adalah structure. Macam saya cakap tadi, saya suruh awak ingat kan, calcium ni dia bagi a good structure. That is because if you see here, the calcium is dia punya because of ionic radius. It has a small hydrated ionic radius. But in a soils that has dominated by sodium, contohnya macam kat kawasan Mediterranean area, ada kawasan yang tinggi sodium, the structure are not good. Okay, that is because of it is dominated by sodium, and sodium ni has a large hydrated ionic radius. So susunan soil tu is like kita call it as dispersed. Nampak structure dia macam mengembang. Okay, compared to bukan lower pH ni bukan maksudnya pH slightly lower pH than the apa ni alkaline soil lah. Okay, so clay dispersion, kita call it as clay dispersion. Kita tak suka yang disperse. The soil in dispersed condition is not good, meaning that it doesn't have a good soil structure. Okay, so the calcium, iron and aluminium coating that act as a strong fortificating and cementing agent in acid soils are largely lacking in alkaline soil. Okay, we need that in stable amount calcium, iron, aluminium coating ni. However, in sodic soil ataupun in alkaline soil, kita tak jumpa langsung this. Okay, it is dominated by what we call as sodium and potassium. So usually sodium yang paling banyak. We call this as monovalent ions. Okay, these monovalent ions are easily leached from acid soils but are still largely unleached ataupun dia stay in a alkaline soil. Okay, so these types of clay are dominant in alkaline soils are especially susceptible to dispersion. Okay, when the soils are said to be dispersed, meaning that the soil structure are not good. Okay. Okay, so these are few types of the problems is kita call it as a salt affected soils. Okay, so in a salt affected soil, about 320 millions of hectare of land in this world. Okay, usually it covers Australia, Africa, Latin America, Middle East. Okay, so by it name by nama dia salt affected soils, we know that there is accumulations of salt. So next week we will go what is the problem with these types of soil. Okay. So kita stop sampai sini. Ingat development of salt affected soil. So any question tak? I think sebab kita habis kelas lambat ni, can we start our tukar lagi? Okay, announcement. Can we do our midterm at 2:30? 2:30 semua dah ready Bukan ada yang baru masuk make sure 2:30 you are already in. Okay?
Boleh.
Okay.
Okay.
Okay, so we meet you at 2:30.